Have you ever heard of the art of turning stone into gold? It's not a myth. It's an ancient technique that actually exists, passed down through generations of craftsmen. Today, we will enter a world where fire is the brush, metal is the soul, and every rough stone is transformed into precious light. Each lump of rough or heavy and dark in color was pounded by the craftsman with a hammer. Then, everything was gathered and put into a stone mortar. There were no machines, just human strength and steady pounding, for many hours. Because gold is not on the surface. It is hidden deep and only appears when people are patient enough to find it. Once the rock has turned to fine dust, the miner begins to sift it. A seemingly light but indispensable step in the journey to find gold. The mineral powder is spread onto the sieve and shaken by hand. The coarse particles are retained, leaving only the finest part where the gold may be hidden. After the screening, the mineral powder is put into the stone mortar. The worker adds water, then begins to grind steadily, slowly, without any hurry. The water helps wash away the impurities, while the rotation of the stone mortar grinds away the remaining roughness. It all happens quietly, but precisely to the beat. Once the mineral powder has been finely ground and soaked in water, the miner takes it to a wooden pan, a traditional tool that has been used for panning for gold for centuries. The pan is used to separate gold from other materials, such as sand, gravel, mud, based on the difference in specific gravity. Gold has a very high specific gravity of about 19.3 g/cm superscript 3, much heavier than normal sand and gravel of about 2.6 g/cm superscript 3. The pan is tilted at a certain angle, usually from 7 to 15 degrees, depending on the flow and type of material where the water flows through, such as a stream, small river, or a water pump. The crushed raw or gold-containing sand and gravel is slowly poured into the upper end of the pan. The water flows through the pan, washing lighter materials such as sand, mud, and small gravel to the bottom. Inside the gold pan, there are often ridges, grooves, or special rubber mats called riffles or miner's moss that are designed to create vortexes and trap the heavier gold particles. As the water flows through, the gold sinks and is trapped in these crevices, while the lighter materials are washed away. The first grains of raw gold appeared, small and dark, mixed with sand and dust. The craftsman poured them onto a heated cast iron pan. The heat helped to push out all the steam and evaporate any remaining organic matter. In that crackling heat, the gold began to shrink, concentrating each small grain. Once completely dry and clean, the gold powder is divided into small pieces by the craftsman. Each piece is carefully wrapped, in preparation for the final step, where the gold will be called its true name, no longer as mineral dust, but as a true precious metal. When everything is ready, the worker starts to light the furnace. The furnace is built of heat-resistant clay, keeping the temperature stable for many hours. The coal is stacked in layers, dry and even, so that when the fire starts, the coal can burn continuously without losing steam. On one side of the furnace is a hand fan. Each time it is pulled, a gust of wind blows up the fire. The worker must listen to the sound of the furnace, look at the color of the coal, feel each wave of heat, to keep the fire at the right golden temperature. Just half a blow wrong is enough to turn all the effort into ashes. The fire had reached its peak. The craftsman gently placed each packet of gold powder inside. As soon as it touched the heat, the shell crumbled, and the powder began to melt. A faint light like liquid honey gradually appeared among the red coals. As the gold begins to melt, the craftsman gently sprinkles in a handful of white powder called borax, a secret metal refining technique that has been used for hundreds of years. Borax not only cleans the surface of the gold, but also helps to collect small pieces of debris, pushing impurities to the surface for easier removal. Just a little, but enough to make this precious metal melt smoothly, shining like liquid sunlight. In the glowing firelight, the gold flowed in streams, but it was not yet completely pure. The remaining impurities gradually rose to the surface, forming a thin layer of air bubbles. The craftsman used a long iron bar, gently brushing away each streak, precisely, decisively, leaving no trace behind. This was the final filtering step, no noise, no show. Only the eyes and hands knew what was discarded and what was kept. Once refined to the last detail, the gold is gently removed from the furnace. Each drop of gold is dropped directly into cold water. There is no more rock dust, no more ash. Only pure gold remains. Would you believe that centuries ago, people knew how to make pure silver using only their hands, fire, and raw stones? An ancient technique, thought to be lost, is still preserved and practiced by dedicated craftsmen. Follow the steps of turning raw ore into shining silver, without machines, without chemicals, just with wisdom and experience passed down through generations. Before the silver can take shape, each of these rough stones must pass through its first test. The miner uses a heavy hammer to break each block of ore, patiently peeling back the layers of time. There are no crushers, no engines, just stone mortars and human power. Batches of ore are fed into the mortar, pounded rhythmically by foot, for hours on end, until they become fine dust, ready to begin the journey of transformation into precious metal. Once the rocks have been crushed into a fine powder, the powder is spread onto a sieve and shaken by hand. The larger particles, which are not yet fine enough, are retained. Only the finest part, where the silver is hidden, is retained for smelting. In this era, it is hard to imagine that a familiar dish like sticky rice could become an important ingredient in metallurgy. After screening, the mineral powder is mixed with sticky rice, a sticky and sticky starch, to form a thick, easily shaped mixture. It is not by chance. Sticky rice helps the powder coagulate, retains heat evenly when fired, and contributes to revealing the pure silver layer inside the stone. When the mixture has reached the right consistency, the worker begins to take small handfuls. Each ball is rolled into a ball by hand, evenly and firmly. No molds or presses are needed. Everything is shaped only by feeling and experience accumulated over the years. The ore pellets, once shaped, are not fired immediately. They must first be exposed to the sun and wind for half a month. This is not just to dry, it is to allow time to penetrate every fiber of the material, to allow the earth, water, fire, and air to blend together. Half a month passed, and each ore was now ready for the greatest test, the furnace. The worker gently placed each one inside, covered it with coal, and began to pull the bellows. There were no temperature gauges, no modern sensors, just ears listening to the sound of the fire, eyes watching the color of the coal, and the steady rhythm of his hands blowing air for hours. This was a life or death moment, because if the timing or the fire were even slightly off, the silver would not form. Once the coal is red hot, the craftsman covers it with a layer of dry straw. The layer of straw helps keep the heat stable, creating a slow, even firing environment and reducing the amount of oxygen that comes into direct contact with the ore, preventing the silver from burning away during the smelting process. The fire had done its job. The coals were gone, the straw was gone. From beneath the ash, the craftsman to collect the remains, the sulfur-containing or fragments, which would be further processed to extract pure silver. The craftsman on to the crucial stage, smelting the lead. Lead, a heavy, soft, and easily melted metal, is used as a medium. When melted, it has the ability to absorb the silver from the ore, separating the precious metal from the rest. The craftsman each block of lead into the furnace, carefully controlling the fire. Too high a temperature will ruin everything, and too low, the silver will not appear. When the lead was red hot, the craftsman began to add sulfur ore. At that moment, a silent reaction took place. The silver began to leave the impurities, hiding in the boiling lead. There was no explosion, no flash, only heat, silence, and the worker's silent hand keeping the process going in perfect balance. The fire died down. From the kiln, a glistening mass of metal emerged. Not pure silver, but an alloy, where the silver lay hidden among the aluminum and impurities. Everything needed one final purification. To extract the true silver, the fire must be rekindled once more. The craftsman spreads a thin layer of ash at the bottom of the furnace. Then he digs a small hole in the middle of the furnace, carefully placing the alloy in the center. A layer of charcoal is placed on top, and the fire is rekindled. But this time, it is not for melting, but for purification. One final heating, one final sifting, to reveal the silver, no longer hidden by any impurities. After several firings, the silver was finally revealed, but not quite pure. Impurities still clung to the surface, like a layer of undissolved luster. A basin of clear water was mixed with alum, colorless, odorless, but a solution capable of washing away the last layer of impurities on the silver's surface. The silver was dropped in and lay quietly, and like a mirror that had just been polished, the light of the precious metal gradually became clear.